Students, let me take up the next question. The question is like this. When an ideal monatomic gas is heated at constant pressure, fraction of heat energy supplied which increases the internal energy of gas is. Options are like this. Option A 2 by 5, option B 3 by 5, option C 3 by 7, option D 3 by 4. Students, in this problem they are asking to find out the fractional change in the internal energy, that is change in internal energy to the amount of heat energy supplied, that is delta U by delta Q they are asking, they are expecting that. Now, as we know that whenever the amount of energy is utilized as completely the internal energy means that energy has to be supplied at constant volume. So, the change in the internal energy can be taken as, change in internal energy can be taken as M into CV into change in temperature divided by the amount of heat energy supplied. Clearly in the problem they are telling that it is at constant pressure. So, M into Cp into delta theta. So, cancelling the common terms in numerator and denominator, the left out term is Cv by Cp. Cv by Cp. As per the definition, gamma is Cp by Cv, but here we have Cv by Cp, so it should be equal to 1 by gamma. And also we know that for monatomic gas, gamma value is 3 by 5. So, 1 by gamma should be equal to 3 by 5. ವಿದ್ಯಾರ್ಥಿಗಳೇ, ನಮ್ಮ ಮುಂದಿನ ಪ್ರಶ್ನೆ ಹೀಗಿದೆ. 2 rods, one semicircular and other straight, of same material and of same cross sectional area are joined as shown in the figure. The points A and B are maintained at different temperatures. The ratio of the heat transferred through a cross section of a semicircular rod to the heat transferred through a cross section of the straight rod in a given time is. The options are like this. Option A 2:pi, option B 1:pi, option C pi:2, option D 3:2. ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಈ ಪ್ರಶ್ನೆಯಲ್ಲಿ ಎರಡು ಮೆಟೀರಿಯಲ್ನ ಇಟ್ಟಿದ್ದಾರೆ, ಒಂದು ಸ್ಟ್ರೈಟ್ ರಾಡ್, ಇನ್ನೊಂದು ಸೆಮಿ ಸರ್ಕ್ಯುಲರ್ ರಾಡ್. ಬಟ್ ದೇ ಆರ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ವಿತ್ ದ ಸೇಮ್ ಮೆಟೀರಿಯಲ್. ಅಂದರೆ ಥರ್ಮಲ್ ಕಂಡಕ್ಟಿವಿಟಿ ಎರಡೂ ಮೆಟೀರಿಯಲ್ಗೂ ಸೇಮ್ ಇರುತ್ತೆ. ಮತ್ತು ಎಂಡ್ಸ್ ಆಫ್ ದ ರಾಡ್ ಎರಡಕ್ಕೂ ಕೂಡ ಸೆಮಿ ಸರ್ಕ್ಯುಲರ್ ಎಂಡ್ಸ್ ಮತ್ತು ಸ್ಟ್ರೈಟ್ ರಾಡ್ ಎಂಡ್ಸ್ ಎರಡೂ ಕೂಡ ದ ಟೆಂಪರೇಚರ್ಸ್ ಆರ್ ಮೇಂಟೈನ್ಡ್ ಅಟ್ ದ 2 different temperatures. Let us say one is θ1, the another one is θ2. They are asking what is the ratio of the amount of heat flowing in the circular rod to the amount of heat flowing in the straight rod. Students, the amount of heat flowing in a conductor is given by the formula Q equals to K into A into change in temperature, that is θ1 minus θ2 into time divided by the length of the rod. ಈ ಪ್ರಶ್ನೆಯಲ್ಲಿ ಇರುವಂಥದ್ದು ಸೇಮ್ ಮೆಟೀರಿಯಲ್, ಕೆ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇರುತ್ತೆ, ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಸೇಮ್ ಇದೆ, ಎಂಡ್ಸ್ ಆಫ್ ದ ಸೆಮಿ ಸರ್ಕ್ಯುಲರ್ ಎಂಡ್ ಮತ್ತು ಎಂಡ್ಸ್ ಆಫ್ ದ ಸ್ಟ್ರೈಟ್ ರಾಡ್ ಎರಡೂ ಕೂಡ ಮೇಂಟೈನ್ ಅಟ್ ದ ಸೇಮ್ ಟೆಂಪರೇಚರ್ಸ್ θ1 ಆ್ಯಂಡ್ θ2. ಎರಡೂ ರಾಡ್ಗೂ ಟೆಂಪರೇಚರಲ್ ಡಿಫ್ರೆನ್ಸ್ ಕೂಡ ಸೇಮ್ ಇದೆ. ಹಾಗಾದರೆ ಹೌ ದ ಹೀಟ್ ಎನರ್ಜಿ ಆ್ಯಂಡ್ ದ ಲೆಂತ್ ಆರ್ ರಿಲೇಟೆಡ್ ಅಂದರೆ ದೇ ಆರ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಹಾಗಾದರೆ amount of heat energy flowed in the semicircular rod to the amount of heat energy flowed in the straight rod ಏನಿರುತ್ತೆ. Since the amount of heat energy flowing is inversely proportional to the length, this ratio should be equal to the length of the straight rod divided by the length of the semicircular. The length of the straight rod should be equal to the diameter, that is 2r, and the length of the semicircular is half of the circumference, that is pi r. So, the length of the straight rod is diameter, that is 2r, length of the semicircular arc, that is half of the circumference, that is pi r. So you can cancel with r. So the left out term is 2 divided by pi. So the ratio of the heat energy flowing in the semicircular rod to the amount of heat energy flowing in the straight rod is equal to 2 divided by pi. So the ratio should be 2:pi. So the correct option is option A. ನಮ್ಮ ಮುಂದಿನ ಪ್ರಶ್ನೆ, 3 rods made of the same material and having the same cross section have been joined as shown in the figure. Each rod is of the same length. The left and right ends are kept at 0 degree Celsius and 90 degree Celsius respectively. The temperature of the junction of the 3 rods will be, options are like this. Option A 45 degree Celsius, option B 60 degree Celsius, option C 30 degree Celsius, option D 20 degree Celsius. Students, they are asking to find out the junction temperature, that is at the point here. So let us say that junction temperature is theta. They are asking to find out what is the theta, junction temperature. Clearly in the diagram, when the amount of heat is flowing in the first rod A, let us say that amount of heat is Q. At the junction, that amount of heat is going to split. Part of it is flowing in B, let us say Q1. Remaining amount of energy is flowing through C. As per the conservation, energy should be conserved. So definitely Q should be equal to Q1 plus Q2. And also they are telling that the rods are of same length, same material, and also no doubt of same cross sectional area. Students, we know that the amount of heat energy flowing in a given interval of time t seconds is the ratio of increase in temperature to the thermal resistance. But unfortunately we have the same cross sectional area and the same length, so definitely the resistance of each rod should be same. ಹಾಗಾದರೆ amount of heat energy flowing through the rod A ಏನಂತ ಬರೀಬಹುದು? Change in temperature divided by the thermal resistance of that rod, that is theta minus 0, that is theta, divided by the thermal resistance of the rod A, that is R, which is equal to, similarly define that Q1 for the metal rod B, 90 minus theta divided by thermal resistance of the rod B. Thermal resistance of the rod A and the thermal resistance of the rod B are same, plus the amount of heat flowing through the rod C, that is 90 minus theta divided by the thermal resistance of the rod C. So since the denominator get cancels, so minus theta minus 2 theta, take to LHS, so it becomes 3 theta, which is equal to 90 plus 90, 180. So theta should be equal to 180 by 3, that is 60 degree. So the correct option is option B. So the junction temperature is 60 degree Celsius. Students, please make a note of this formula. Amount of heat energy flowing in a given interval of time, use the formula increase in temperature divided by the thermal resistance. Don't go for K into A into theta 1 minus theta 2 into T divided by D, because it takes lot of steps.